Example 1, solve the triangle. So is what it means to solve a triangle is find the remaining or missing sides and angles. And is what we're going to do is we're going to round angles to the nearest degree, and we'll round lengths to the nearest tenth. And let's go ahead and start off with actually finding big B here. It's the only angle we're missing. And you might remember from geometry that the sum of all the angles in a triangle add up to 180. So we have 33 plus 128 plus B is equal to 180. And we'll go ahead and we'll just solve for B here. So B should be equal to 180 minus 33 minus 128. And this gives us B is equal to 19 degrees. Okay. So we already have one piece of this done. Now, it's up to us now to decide whether we want to try and find side B or side C. And it's not going to matter here because we know all three of these angles. We can just choose to start with whatever one we want. So let's just start off by actually thinking about what that law of sines and cosines looks like. Remember, I'm actually just going to move this up so we can see it. Sine of A over A equals sine of B over B equals sine of C over C. So we don't actually usually use all that at once. We'll usually just use 2/3 of it. And here's what I mean. I'm going to go ahead and write down sine of 33 degrees over the corresponding side length of 16. And then over here, I'll do sine of some other angle. How about sine of 128? And the side opposite of the 128 is this side C over here. So I'll write over C. And is what we want to do is just start solving for C. And I'm going to move that down here so that it's not so far away from the rest of our work. There we go. So why don't we actually start off by cross multiplying? So if we cross multiply here, we're going to get C times sine of 33 degrees is equal to 16 times sine of 128 degrees. And then we'll divide each side of the equation by sine of 33 degrees. And so this gives us sine, or C is equal to 16 sine of 128 all over sine of 33 degrees. And just make sure your calculator is in radians, and go ahead and type this in, and we should be getting, let's see, should be getting approximately, right, we want to round this to the nearest tenth, so 23.1, and our units were centimeters. And so the only other thing we're missing is side B. And we can find it in a pretty similar fashion. We can actually start off by writing the same thing, sine of 33 over 16. So all I'm really doing is I'm just using a corresponding angle inside is equal to, and in this time, instead of thinking about C, we're going to be thinking about B. So we'll have sine of big B, which is 19 degrees, all over. And the side opposite of B is little b. And we can do the same thing. We can cross multiply and solve for B. So we'll have B sine of 33 degrees is equal to 16 times sine of 19 degrees. which means B is equal to 16 sine of 19 all over sine of 33. If we round this to the nearest tenth, since this is a side length, it's going to give us 9.6 centimeters. On to example 2. Find the angle B to the nearest degree. Well, again, this is an oblique triangle, so we can't use SOHCAHTOA. So our only tool that we know of yet is the law of sines to deal with these oblique triangles. Now, in order to even be able to use law of sines, you need to have or need to know a corresponding angle and side, and we are lucky enough we do. This is going to allow us to write one side of the equation, and so we could write sine of 38 degrees over 20 is equal to, and our goal is to find B. So sine of B all over, and let's see what's opposite of the angle B. Looks like that is 31.8 feet. And so now we'll go ahead and we'll cross multiply, and we'll solve for big B. And to solve for sine of B, we would just need to divide both sides of the equation by 20. And that would look like this. And then finally, we could use sine inverse here. So B is equal to sine inverse of 31.8 sine of 38 degrees all over 20. And if you go ahead and plug that in your calculator, let's see what we get. If we round to the nearest degree, you should be getting about 78 degrees. Now, does this make sense? Let's look at that picture. And it doesn't make sense. The angle B in this picture is, it's bigger than 90. Okay, right? It's an obtuse angle. And 78 degrees is an acute angle. So this doesn't make sense. Let's think about why we're getting the wrong answer here, and think about what we can do to make sure we get the correct answer. Let's go ahead and make a little sketch here. So these are going to be just our X and Y axes, and I'm going to try and put a circle over that. There we go, good enough. And then next is what I'd like to do is sketch this angle here. So that 78 degrees is a first quadrant angle. And actually, let me use the line tool here. There we go. And actually, this angle would probably look something more like this here. Now, the thing is sine inverse, remember, it only gives us angles between minus pi over 2 and pi over 2. Or if we're in degrees, minus 90 and 90. So of course sine inverse didn't give us this B here that we were looking for. Okay. And is what that really means is we've found some other angle. Let's just call it B prime. And is what we're really looking for is another spot on the unit circle another spot on the unit circle that results in this y value. And that y value is kind of messy, 31.8 sine of 38 over 20. But to find it geometrically, all we need to do is just go straight across the unit circle. Because if we do that, the y value will not change. And let's sketch in this new angle. There we go. So this is the angle we're looking for, but the thing that is going to be useful to us is that this B prime here, that's also this angle, okay, right? This is symmetric about the y-axis. And something else that's going to be useful to us is this is 180 degrees if we've rotated to here. So if our goal was to actually find this angle here, this obtuse angle, which would be B, let's see how to compute that. B should be equal to 180 minus B prime, right? 180 to go this half rotation. There's B prime left in here, so what we're left with is B. And if we go ahead and compute this on our calculator, remember we already have B prime on our calculator. So you do 180 minus B prime is what we're going to get is 102 degrees.